and frequency distributions, then histogram and Ogive. Now first of all, dot plot. What is dot plot? Dot plot is actually use of sign of dot to indicate each and every value on x-axis. So we will have to prepare a horizontal axis. Okay. Now first of all, we have to decide which is the lowest value in this data. It is 6, which is an integer fortunately. And what is the highest value? It is 15.8. 6 and 15.8. The next integer after 15.8 is 16. So a range of our horizontal axis will be from 6 to 16. All integer, first of all we will plot all integers on the horizontal axis. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Now the values are with 1 decimal place. The lowest 1 decimal place value is 1 and the highest is 9. So we need up to 9 in this data. Say this is 0.5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same way 1, 2, 3, 4, 5, 6, 7, 8, 9. Again 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Next 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Half framer. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And in the last segment 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, on graph paper it is very easy to write down everything. Now just use the use of dot point to indicate each and every value on this chart. Say first is 8.9. So 8.9 it comes here. We can use the mark of centimeter for this purpose on the graph paper. Next is 10.2. 10.2. 11.5. 11.5. 7.8. 7.8. 10. 10. 12.2. 12.2. 13.5. 13.5. 14.1. 14.1. 10 again. Now 10 again. Use the other mark of centimeter. 10 again. 12.2 again, 12.2. 6.8, 6.8. 9.5, 9.5. 11.5, 11.5 again, so we will use the upper mark. 11.2, 11.2. 14.9, 14.9. 7.5, 7.5. 10 again, 10 third time, so use the third centimeter mark. 6, 6. 15.8, the highest value. 15.8. And the last is 11.5. 11.5. Again we are going to use the third centimeter mark. This is the dot plot. Just give a title, dot plot. Yes, this is dot plot. Exact value is actually indicated by dot on the graph paper. This is very simple, and this can be used as the substitute of telebar marks for the purpose of frequency distribution. Okay, now complete it. Okay, now first of all, for the purpose of preparing a frequency distribution, we have to determine the class intervals. What should be the class interval? How many class intervals should be there? First of all, the lowest number is 50, lowest number is 6, highest value is 15.8. So the lower limit of any class can be an integer. Say it can start from 6. The upper limit of any class can be any number 0.9. Say last will be 15.9. So 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. We have total 10 integers. So first alternative with us is to use 10 class intervals with class interval of 0.9, 6 to 6.9, 7 to 7.9, 8 to 8.9. This is one of the alternatives. But the total number of cases are actually, how many cases are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 into 2, 20. So total of the frequency is just 20, very small. So in this case it is not advisable to use the large number of classes, say 10. On an average, a frequency cannot be more than 2 if it is equally distributed. So we are going to reduce the class interval. Another best alternative with us is go for double class interval. 6 to 7.9, 8 to 9.9, 10 to 11.9, 12 to 13.9 and 14 to 15.9. Only 5 class intervals will be there. So which is the best one? Second alternative is the best one. So we are going to prepare a frequency distribution. Class 6 to 7.9, 8 to 9.9, 10 to 11.9, 12 to 13.9 and 14 to 15.9. Now frequency. What about frequency? Now we are not going to use the telemark or telebar. We will use the dot plot for the purpose of getting frequencies. We just have to count the number of dots. Instead of telemarks or telebars, we just have to count number of dots within the range. Say first is 6 to 7.9. Yes, 7.9 is here. Okay. This is the 7.9 here. How many dots are there? Yes, sorry, 7.9. Yes, next is 9.9. Then 11.9. 13.9 and here 15.9. Just we have to count the number of dots between the two bars. Say in first case 6 to 7.9, 1, 2, 3, 4. So this 4 shows the frequency of class interval 6 to 7.9. Now 8 to 9.9. How many dots are there? Only 2. Yes, 2. Then to 11.9. The highest number of dots are there. 1, 2, 3, 4, 5, 6, 7, 8. Next is 12 to 13.9. 1, 2 and 3 dots. And the last 14 to 15.9. 1, 2 and 3. The total must be 20. This is our frequency distribution, very used to prepare with the help of dot plot. Got it? Can I remove it? Yes, next is relative frequency. Once more, what is relative frequency? Frequency divided by total of frequency. 4 divided by 20. What will be the number? It should be 0.4.2. 2 divided by 20 means 0.10. 8 divided by 20, 0.40. 3 divided by 20, 0.15. Again 0.15. The total should be 1. 20 divided by 20. Clear? Okay, next is percent frequency. What is percent frequency? Yes, relative frequency multiplied by 100. So first is 20%, second 10%, then 40%, 15%, and last is also 15%, until ultimately the summation should be 100. Yes, now it is turn of cumulative frequency. And first is simple cumulative frequency, that means cumulative frequency of this column. What is accumulation from first number to the last number? 4 as it is, 4 plus 2, 6, 6 plus 8, 14, 14 plus 3, 17, and 17 plus 3, 20. It should be actually exactly equal to the total of frequency. Now, cumulative percent frequency. cumulative percent frequency, cumulative of this. First 0.20 remains same, 0.20 plus 0.10, so 0.30. And the second method to arrive at this value is 6 divided by 20. First is 4 divided by 20, second is 6 divided by 20. Now 0.30 plus 0.40, it comes to 0.70. Or in another way, 14 divided by 20. Next is 0.70 plus 0.15, 0.85. 17 divided by 20 also gives us 0.85. And 0.85 plus 0.15, the ultimate amount is 1. 20 divided by 20 is also 1. And no summation of the cumulative frequency, please. The last is, sorry, this is cumulative relative frequency. I am very sorry. Now cumulative percent frequency. Percent frequency, first is 20%, second is 10. 20 plus 10, 30%, or otherwise 0.2 into 100, 20%, 0.3 into 100, 30, 30 plus 40, the next is 70, and in another way 70 means 0.70 into 100, that means 70%, 70 plus 15, 85, or 0.85 into 100 means 85%, 85 plus 15 equals to 100, or 1 into 100% is also 100. So this is cumulative frequency distribution. Actually these are 6 different frequency distributions. This is simple frequency distribution, this is relative frequency distribution, these two columns actually are percent frequency distribution, again cumulative frequency distribution, cumulative relative frequency distribution, and cumulative percent frequency distribution. Now, is it clear? Yes. So next point is histogram. Yes. Histogram. Vertical axis or y-axis, yes, and x or horizontal axis. Now starting point is 6, so there is no problem with the measurement, but highest frequency is 8. So we need up to 8 only. So we will go with scale of 1 per centimeter. 1, 2, 3, 4, 5, 6, 7, and 8. What is it? This is frequency. On x-axis or on horizontal axis, we are going to take classes. The first is 6 to 7.9. The second is 8 to 9.9. Third is 10 to 11.9. Fourth is 12 to 13.9. And the last fifth is 14 to 15.9. histogram, we just require to draw bars with the height of frequency. The frequency of class 1, 6 to 7.9 is 4. Yes, is it 4? Okay. So a bar up to height of 4. What is the frequency of class interval 8 to 9.9? It is 2, yes. So height up to 2 only. If we do not use the sign, it is also okay. The height of the third will be 8, yes. 8. And the height of last 2 bars will be the same up to 3. Ogive means cumulative frequency curve, or more precisely less than cumulative frequency curve. On vertical axis we will write cumulative frequencies, or CF. On horizontal axis we will write upper limits, or you can say class. We will write the first lower limit only, 6, and then all upper limits, 7.9, 9.9, 11.9, 13.9, and the last is 15.9. Now the last cumulative frequency is 20, so we will go up to 20. We can use scale of 1 or 2. Here we are going to use scale of 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Now just plotting of the cumulative frequency with relevant class interval. First upper limit is 7.9 and cumulative frequency against it is 4. What is the interpretation of these 4? Out of 20 data values, 4 data values are less than or equal to 7.9. The second cumulative frequency is 6 against 9.9, or class interval of 8 to 9.9. The interpretation of this 6 is 6 data values out of 20 are less than or equal to 9.9. The third against 11.9 is 40. 40. The interpretation of these 14 is 14 data values out of 20 are less than or equal to 11.9. The next is 17. 17. These 17 values are less than or equal to 13.9. And the last is 20. That means all the 20 values are less than or equal to 15.9. The highest data value is 15.8. So precisely all the 20 data values are less than 15.9. Now attach the dots with free line. And in this data the lowest value is 6. That means no value is less than 6. So cumulative frequency at 6 is actually 0. And we can attach it to the horizontal or x-axis in this way. This is actually a sketch of Ogive, so perfection cannot be there. The real shape of the Ogive can be like this. This shape is actually called Ogive. Got it? Yes?